In this video, we're going to define what a galaxy is and the different types of galaxies that exist in our universe. So a galaxy is a collection of stars and cosmic material such as dust and gas that's held together by the gravitational force between those items. So the pull of gravity, remember, is an attractive force, and with all of that dust and gas swirling together, as that pulls on each other because it has mass, they're going to form stars, and then once stars exist, they're going to pull on each other because they have mass, and then you end up with these groupings of stars that are moving together through the universe. They come in a variety of shapes and sizes, and they contain millions to billions of stars. We are going to focus on three main types of galaxies this week, and they are the spiral, elliptical, and irregular galaxies. Spiral galaxies have the following characteristics. So they'll have a spiral shape with a central bulge, which you can see here. That's usually composed of older and redder stars, so that's why it has that yellowish, orange, red tint. And so that is the first characteristic of all spiral galaxies. They will also have these arms, which are made of gas, dust, and stars. And so you can see here how they swirl around, almost looking like a hurricane. Those are the arms that we're talking about. And they typically contain anywhere from 1 billion to 1 trillion stars. And two quick examples of spiral galaxies are the Andromeda Galaxy, which is the largest spiral galaxy that's the closest to us, and then the Milky Way, which we are a part of. So again, two examples of spiral galaxies. And again, the Milky Way looks a little different. We don't see that spiral shape because we are inside the galaxy, not looking at it as an outside observer. Next up are elliptical galaxies, and those are characteristically oval-shaped or elliptical. An ellipse is an oval, and they are usually made up of reddish yellow-colored stars because those stars in these galaxies tend to be older than some of those bluish stars that you saw in the spiral galaxy we just looked at. So again, they usually have a reddish yellow tint because the stars are a little older. And there's a lack of gas and dust swirling because most of the stars in these galaxies have already formed. Because they are on the older side, there's less gas and dust just floating around within the galaxy. And here are some examples. So we've got Mafe 1, NGC 1316, and then ESO 325 G004. Some of the galaxies do not have cool names like the Milky Way. They are numbered because there are so many of them. But this just shows you some different ways that elliptical galaxies appear. And again, you can see that yellowish tint in all the pictures. Last but not least, we have our irregular galaxies. And these galaxies tend to be a little bit smaller and dimmer and have less organization than spiral and elliptical galaxies. So there's no consistent shape that all irregular galaxies have. And they usually are formed due to collisions, so two galaxies colliding with one another, and or gravitational interactions, meaning that if it gets too close to another galaxy, the shape is distorted and disformed and changed from what it might have looked like originally as a spiral or elliptical galaxy because that pull from gravity is changing the shape. So again, it can form due to collisions and or interactions with other galaxies due to that force of gravity attracting and pulling on it, changing its shape. And here are two examples. As you can see, as long as it has some stars and it forms that irregular shape, that's not a spiral, it's not elliptical, then it falls into the irregular galaxy category. Now there are smaller galaxies out there, and they're called dwarf galaxies, and they contain only a few million to a few billion stars max, unlike, for example, the spiral galaxies that could have trillions of stars. But these are the most common type in our universe. They are typically irregular in shape, but they can be spiral and they can be elliptical too. And they're not very bright, so it does make them a little bit harder to detect, but they are out and about in our galaxy and our universe. So again, they're a little bit smaller. That's why they're called dwarf galaxies, and they are found throughout our universe. You're now going to continue your learning by watching the Crash Course Astronomy video in the next tab over, called Galaxies Part 1, and it's Crash Course video number 38, and you're going to follow along with your note sheet. And since I have gotten a few questions about the note-taking sheet for these videos, just to go over it, if it says type notes here, that means you're filling in the blank, you're completing the sentence, or you might have to write a little bit more information. Anytime it says choose, you are picking one of these options to complete the sentence. So for example, elliptical galaxies are generally populated by, and then you would pick either older or younger to complete the sentence, and you can delete the rest to keep your notes easier to read. And then, for example, if this is true or false, you'd be able to choose the one that it is and then delete the one that it's not to keep your notes clear. So again, I just wanted to go through that because I've gotten some questions about what to do with the note-taking guide. Since we can't watch the video in class with a handout where you'd write in your answers, I felt like this was the best option. So again, please reach out with any questions about types of galaxies and the main characteristics of these galaxies after you've watched our video and then the Crash Course video.